So let's do limits at infinity. So when you are asked to evaluate limits at infinity, all you have to do is to determine whether the function is equally heavy, top heavy, or bottom heavy. Alright, so what will happen if our equation is equally heavy, top heavy, or bottom heavy? So look at this limit, 3x over x plus 3, as x again approaches towards negative infinity. Now if you can see here, the highest degree is 1. Alright, so we have 1, 1. So we are just going to focus on the highest degree and then disregard the rest. And then what we're going to do is just divide whatever is the numerical coefficient of that highest degree. So we have 3 on top and then we have 1 at the bottom. So therefore your limit will approach positive 3. So we are going to use the same principle when answering number 2. So number 2, the highest degree is 2. The same with our denominator. So again, we are dealing with equally heavy. So we have 3 over numerical value of x squared, that is just 1. So again, number 2 will give you 3. Let's do number 3. Now, take note that when you are going to simplify this one, it will only give you x, right? X. This x squared will become x. So again, the same thing. What is the numerical value of x? That is 1. And then at the bottom, we have 2. And again, since this is equally heavy, you're just going to have 1/2. What about number 4? Again, number 4, this is still equally heavy. So we will get what? So when we subtract the square root of 4x squared, this will actually give us 2x. So we will have 2x over 3x. So we have 2 over 3. Where is that? And again, we have actually approaching towards negative infinity. So we will get this. Now let's have number 5. Now if you're going to look at number 5, we are having bottom heavy. So again, we are dealing with bottom heavy. Why is it bottom heavy? Because again, the denominator has the highest exponent compared to the numerator. So when you are dealing with bottom heavy, it will always approach to 0. Alright, so this is just 0. So 0 plus 4, that will give you a positive 4. So the same principle is applied when we deal with number 6. So again, this is still bottom heavy. Bottom heavy. And again, the limit of any polynomial or any rational expression as x approaches towards infinity, if it is bottom heavy, this is always gonna be 0. So this will be 0 plus 3. You will get a positive 3 as your answer for number 6. Now for number 7 and 8, let's try to approach this using our scientific calculator. So again, we have here the cosine of some x variable over x, and then again minus 3. So what will happen to this expression if x approaches towards negative infinity? So I want us to observe if x is negative 10, that is just negative 3.098. And then if we're going to increase the value of x, look what will happen. We will now have negative 0.001. And then what if I'm going to have this one? Alright, so as you can see here, we are actually approaching negative 3. So our answer here should be what? Should be negative 3. Let's try to have more numbers. Negative 1, 1. Alright. Oops. The calculator can handle that one. So, negative, negative, let's say that one. Alright. So, again, we are approaching towards negative 3. Now, the same is true with number 8. So, let's try to make use again of the calculator for us to see what will happen if we are approaching towards negative infinity, sine x over x plus 1. So, let me just change this one into a sine x. So, sine of x. Alright. And then again, calculate. We'll do negative 1000. We are again approaching, no, it's plus 1, sorry. That should be plus 1. So let's do that again. Negative 1000. So we are approaching 0.9999. Let's do that again. 10,000 or 100,000. Alright. So basically we are approaching to what? Towards positive 1. Alright. So that is for number 8. Let's have number 9 and number 10. Now number 9, look at the exponent. We have 1 over x. This is bottom heavy. Alright, bottom heavy. And again, if bottom heavy, as x approaches infinity, this is just 0. So what will happen here? We will get what? This is equal to negative e raised to 0. And again, any number raised to 0 is just 1. And then 1 times negative, our answer will be negative 1. Let's have number 10. Again, number 10 is what? Number 10 is bottom heavy. So every time again you are dealing with bottom heavy, as x approaches towards infinity, that is always 0. Let's do number 11. So number 11, as you can see here, this is actually what? This is actually equally heavy. So since again this is equally heavy, we are going to disregard everything and focus on the numerical coefficients. So we will get actually the cube root of, we have 1 and then we have 2. So we have 1 over 2. And if you're going to simplify this, this is just what? This is just the cube root of 1. That is just 1. And then over the cube root of 2. And again, if you're going to rationalize this one, if you're going to rationalize this one, we are going to multiply numerator and denominator by, let's say, square root of 4. Alright, so let's do square root of 4. This gives us cube root. So we have cube root of 4 all over, this is cube root of 8. Or when simplified, this is now cube root of 4 over 2. So what is that number? That is actually letter C. Now for number 12, we have here a bottom heavy. So this is now 0. And remember, cos 0 is just 1. And then we have here infinity, x. So negative infinity, we have negative infinity and then 1. That will just give us negative infinity for number 12. What about number 13? Alright. So what will happen if again we are going to have what? Limit of e raised to negative x plus 4 as x approaches towards negative infinity. So basically, this will become, let's say for example, we'll have negative number, negative 2. So negative 2. So basically this will become, the exponent will become positive. And then as we approach negative infinity, the exponent will get bigger and bigger and bigger and bigger. And again, this will give us what? A positive infinity. So number 14, look at this one. This is top heavy. So top heavy, so meaning to say, if you are dealing with top heavy, it is approaching towards infinity, and we are approaching towards positive infinity. Therefore, this is again a positive infinity for number 14.